Now what we're going to do is we're going to define some transformations or look at certain things we can do to the expressions for these functions and what happens to their graphs, or how the graphs are transformed when we do some basic things to the equations for these functions. All right, so let's start. The first one that we want to look at is translations. Now let's use y is equal to the absolute value of x for this. And at this particular point, I'd like to show you a little something about your calculator. Now on your calculator, it's possible to get the absolute value of x and to actually look at its graph. So let's do that, or let's start with that. Now, to get the graph of y is equal to the absolute value of x, what we can do is you press y equals to get to the y part. Now, if we want absolute value, that function is in the calculator. The easiest way to get that function is to press the math button. That's the third one down on the left. And then press the right arrow to go over to the num part of the menu. And number 1, you'll see ABS open parentheses. Now, since your calculator doesn't have any wheels, ABS couldn't possibly stand for anti-lock braking system. So it turns out that ABS actually stands for absolute value. So if you press enter at this particular point, notice it will paste ABS parenthesis, open parentheses, in the Y1 place in your register. Now, if you put an X inside the parentheses and close the parentheses, you have y equals the absolute value of x. Now, remember what that graph looked like. It was a V with a vertex at the origin, right? Well, let's give this a try. If we press graph, notice on the negative 10 to 10 window for x and negative 10 to 10 window for y, we get the V. Now, that's going to be the function that we're going to play with a little bit as we start doing some of the transformations. Now, some of the translations. Now, the word translate means to slide. So what we want to do is we want to slide this graph. Now, watch this. If we were to take y equals the absolute value of x, and after we were finished, we would add 3. What that would mean is every y in this second function, let's make this function red, every y in the red function will be 3 units higher than the corresponding y in the blue function. And we can do that quite easily on the calculator. We can just go down to y2 and do math, num, absolute value, x, close parentheses, and then type plus 3. Now, you have to watch the calculator carefully. What it's going to do is it's going to graph y1, then it's going to come back and it's going to graph y2. And as you see these two things being graphed, you can compare what happens on the second one with the first one. So we have press graph. Whoa, that was quick. Well, y is equal to the absolute value of x we had before. Now notice the second one is shifted up 3. Now that makes sense, doesn't it? So y is equal to the absolute value of x plus 3 shifts the absolute value function up 3 units. Now, what do you suppose? Now think about this for a minute. What do you suppose would happen if instead of adding 3 after we had performed the absolute value, we subtracted 2? Now, if you need to pause the video, here's where you'd pause it. Now I'm going to tell you the answer. If we subtracted 2, in other words, if we had y equals absolute value x minus 2, this would shift the graph down 2 units. Let's take a look at the calculator and let's do that. See what happens. Minus 2. And if we look at the graphs, Notice it graphed y is equal to the absolute value of x first, and then the second one is that same graph, but it's shifted down 2. So one of the truths that I want you to learn is that when you add or subtract something from a function after the function has been performed, that has the effect of moving the function up or down, moving the graph of the function up or down. On the last video, we discovered that if you add or subtract something to a function after the function has been performed, that has the effect of moving it up or down, the graph up or down. See, y is equal to the absolute value of x is the v that has its vertex right on the origin. And then y is equal to the absolute value of x plus 3 is the v that is moved up 3 units. Actually, we can do that. Notice the blinker is on this graph up here, and in the right-hand corner of the calculator, it's telling you that that y is equal to the absolute value of x plus 3. And then the one that's down is y is equal to the absolute value of x minus 2. So adding or subtracting a number to a function after the function has been performed has the effect on the graph of sliding the graph up or down, depending upon if you're adding a positive number, it goes up. If you're subtracting a positive number or adding a negative number, it goes down. All right, so that's a slide or a translation. Now, the immediate question that comes to mind is, what would happen if we added or subtracted before we perform the function? Now, look very carefully. What we're doing here on the red function is we're saying absolute value of, now it's the absolute value of x plus 3, or the quantity x plus 3. What happens there? And let's just go into the calculator here, and if I go down to the second one, and I go over to the left parentheses and press delete, and go to the right of the 3 and press an absolute parentheses, now what I have is the absolute value of the quantity x plus 3. Now, let's just take a look and see what happens if I press graph. Notice the one that was up 3 units has now gone 3 units to the left of 0. Now that doesn't seem quite right, does it? Wouldn't you think it ought to go 3 units to the right? Well, let's go back to y equals here, and let's go down to minus 2 and get rid of the delete button here and go over here and press parentheses, and let's see what happens to the bottom one. Whoa! Now the bottom one is gone, and what it has done is it has gone along the x-axis 2 units to the right. See, what we're looking at here now is the absolute value of the quantity x minus 2. Now, so there's a bit of a mystery here, and let's just go ahead and make some, plot some points and plot them and see if we can kind of figure out what's happening. So we have, for the red function, x and y, and we'll start with 0. Now, when x is 0, we have 0 plus 3 is 3, absolute value of 3 is 3. If we put negative 1 in, negative 1 plus 3 is 2, absolute value of 2 is 2. If we put negative 2 in, negative 2 plus 3 is 1, absolute value of 1 is 1. If we put negative 3 in, negative 3 plus 3 is 0, absolute value of 0 is 0. If we put negative 4 in, negative 4 plus 3 is negative 1, absolute value of negative 1 is 1. Let's put negative 5 in. Negative 5 plus 3 is negative 2, and the absolute value of negative 2 is 2. Now let's just plot these points and see what we get. 0, 3 is here. Negative 1, 2 is here. Negative 2, 1 is here. Negative 3, 0 is there. Negative 4, 1 is here. Negative 5, 2 is here. Now notice what happened was this actually, even though its absolute value of x plus 3, it moved the original graph, the blue graph, 3 units to the left. Now, if you look at this chart of values of x's and y's, and actually have done the computations with me, you might see that what's happened is that the absolute value changes what it's doing at the value for x that makes what's inside the absolute value equal to 0. Because anything that's greater than 0, the absolute value does nothing to. Anything that's less than 0, the absolute value changes its sign. So the bend comes in the graph where the quantity that's in the absolute value is equal to 0. So can you see that x plus 3, take the absolute value, actually shifts the graph 3 units to the left. Now, if we follow the same concept, the absolute value of x minus 2, the value that makes x minus 2 equal to 0 is 2, so we would kind of expect that y is equal to the absolute value of x minus 2 would shift it 2 units to the right. And that was our experience on the calculator when we moved that absolute value sign, or actually it was a parenthesis on the calculator, outside of that, so we were doing x minus 2 and then taking the absolute value, it did shift it 2 to the right. Now, there's a couple of things that we're going to learn here. Number one, if you add or subtract to x before you perform the function, and you see the absolute value symbols, function is symbols of grouping. In other words, they also mean do what's inside first. So you can see in these cases, we're doing the add 3 or the minus 2, and then we're taking the absolute value. So if you add or subtract something to x before you perform the function, that is a horizontal effect. In other words, it will slide the graph left or right, and also it slides it opposite the direction you would expect. Another way of thinking about it, and I would recommend that you kind of meditate on this, is it slides it to the 0 of the quantity that's inside the absolute value. So when you're doing an absolute value graph, one of the questions you have to ask yourself is what quantity for x will make what's inside the absolute value equal to 0? And then that's where you probably should start your x's. See, for the red graph, we probably should have started with -3 and then built each way, -2 and -4, -1 and -5, 0 and maybe -6. And that way we'll be sure to find the bend in the absolute value graph. Now, we're working on different transformations, and what we've seen so far is that when we add or subtract, we'll get either a vertical effect or a horizontal effect depending upon whether we add or subtract before or after the function is performed.